And what I'll do is I'll do a discussion 8.1. I'll kind of do a lesson. Then I'll have you guys do some practice problems. I'll put you guys in breakout rooms. And for 8.2 and 8.3, I will recap and have you guys do some problems there as well in breakout rooms. And the hope is to be done by 2 o'clock today. So I don't want to go past that. All right, so share screen. And let me open up, let's see here. I think it's going to be right here. Spring semester, lecture notes, blank, chapter 8. Here we go. Perfect. I'm going to minimize this. All right. So you guys should already have these notes. Hopefully, I think I printed these out before we left for break. Sorry, before we close school. If not, you can always download it. And it looks like there's a lot of stuff here. I think what we'll do is we'll probably do maybe the first 2.5 pages, then we'll go to the classwork after that. I'd like that better. So let's start with the top here. And again, if you have any questions, please let me know. So direct, inverse, and joint variation. We'll start with direct variation. So as the name's implied, this is when 2 variables have a direct impact on each other. Now, what does that mean, direct impact? Let me show you a good example. Circumference of a circle varies directly with diameter. If you forgot, circumference is simply that, pi times diameter. Now, let's do some examples here. What if your diameter is 1? Your circumference is pi. What if your diameter is 2? Your circumference is 2 pi. What if your diameter is 3? Your circumference is 3 pi. What if it's 4? It's 4 pi. What if it's 1/2? It's half pi. So notice that by doubling d, c is doubled. Or by tripling d, c is tripled. So that's what's meant by direct impact, is that both variables change the same way. So you kind of want to think of it as same proportional change. That's all that's happening. And generally speaking, it tends to follow this formula. Y equals AX, where A is called the constant of variation. So in this case, A would be like the pi here. So pi is called the constant of variation because that's something that is doesn't change. It's just a number. And some of you guys that took the PSAT might remember hearing the word constant often. It's just a number. And it's a number that's usually being multiplied or added to something, or it can be even divided or subtracted, but it's a number that's just being attached to a variable and doesn't change. And you kind of just use that as part of your ratio. So in this case, C over D always equals pi. This means that you have a constant ratio. So the ratio for each of these pairs is always pi. That's why pi is called the constant of variation. If you look at another one, example 2, you're driving 50 miles per hour on a highway, distance traveled varies directly with the number of hours driving. So D equals R times T. So you're told that distance varies directly with hours. So your distance is d, and your hours is t. So your constant of variation is r. So when you're asked to write the equation, d equals rt is your equation. We ask for the constant of variation. Constant of variation. Remember, variation means change. D and t change, right? If you double the time, you double the distance. Triple the time, you triple the distance. Halve the time, halve the distance. D and t are changing, obviously, but according to r, the constant of variation. So, for example, you're traveling 50 miles per hour, then for every hour, you gain 50 miles. And actually, because I'm given the number, I should have actually done a 50 there. So I didn't realize that we actually had a number given to us.
What does that say above of variation?
Constant.
Thank you.
Constant of variation. So that's the constant in the equation. It's a number that doesn't change. So that means that d divided by t is always going to equal 50. That means that the distance you travel per unit time or per hour will always be 50 miles per hour. So that's direct variation. Okay, I'm going to go ahead and clear this. But we're okay so far? Okay. So let's move to inverse. Inverse is just the opposite. So again, you're given some examples of direct variation, like some geometry formulas follow that, like circumference with diameter, motion, like distance, rate, and time. So that's just what you see. But inverse variation is the opposite. So this is when
Mr. Omashni.
Yeah.
Farah said she got kicked and she needs
to
be let back in.
I will let her back in. Thank you. Let's do this. Stop share. Go on. There's participants. Let me just unlock it, and she can just come in anytime. Let me turn off the waiting room. And if anyone decides to barge in our room, I'll kick them out. So, yeah, anyone has as far as a cell number or a contact, if it just let her know, she can come back anytime. Okay, thank you for letting me know that. All right, so let's get back on here. And if she's still having trouble, just someone let me know and I'll figure it out. Okay, so inverse variation. This is when two variables in opposite directions or inversely, we'll say. It follows this formula. A is still called constant variation, but notice now it's A over X, not A times X. So they're going in opposite directions. A good example would be, say like y equals 2 over x. That's just this very simple equation. X is 1, y is 2. X is 2, y is 1. X is 4, y is 1/2. If x is 1/2, y is 4. Notice how when x increases, y decreases. Or when x decreases, y increases. They're going in opposite directions. So basically, x goes up, y goes down, or x goes down, y goes up. But it must do so in a proportional fashion, meaning if you double x, you have y. Or if you have x, then double y. A good example would be if you're, you're next door neighbor is doing construction to their house, right? And they got 4 people working there, and they say it's going to take 10 weeks. You're like, oh my God, I got to deal with 10 weeks of all this noise and commotion, and people parked in front, and just yelling and doing God knows what. So what if they double the workforce? What if they go from 4 workers to 8 workers? Then you think it should take 5 weeks instead of 10 weeks. Notice how they go in opposite directions, right? So that's what's meant by inverse variations. If you double something, the other thing gets half, or if you triple it, then you divide by 3. If you quadruple, you divide by 4. So here's a good example, example 3. If an plan offers 20 gigabytes of shared data, what is the relationship between the number of people on the plan and the data limit per person? So we'll say the number of people, and so let me make sure. Good, far back, awesome, right, great. So let me make sure. Yeah, let's say the number of people is X. The data limit per person is Y. So if you think about it, it would be Y equals the total data divided by the total people. Well, total data is 20. People we're talking about, X. The equation is simply Y equals 20 over X. So for example, just me and my wife are on our data plan, so we just use up 10 gigabytes each, right? Assuming we do it equally. But let's say that my 2 small children, when they get older and they get cell phones, then it would be 5 gigabytes per person, right? Because it would be 2 and 20 divided by 4. So all of a sudden, 2 people, 10 gigabytes per person. But now I got 4 people on the plan. That's 5 gigabytes per person. Of course, I probably would then want to upgrade and say, oh, I need more memory. But yeah, if I just kept the plan the same, then obviously that goes down. So notice if I double the people, the gigabytes per person goes down. Here's another one. It takes me 5 hours to clean my house. If I get my fiance to help me clean it, it takes half the time. That would make sense, right? Is this direct or inverse? Obviously, it's the inverse. The reason why is that, so this is your, give me one sec here. Number of people and total cleaning time, okay. The number of people will be X. Total cleaning time will be Y. Just Y equals 5 over X. Because if you have one person, it takes 5 hours, right? If you have 2 people, if your total takes half the time, it'd be 2.5 hours. So this equation would get that for me. So that's another way of looking at it. Y equals 5 over X. Another way you can think of this too, X times Y equals 5, or X times Y equals 20 for the previous example. So in this case, you have a constant product. Instead of a constant ratio, you have a constant product. So X times Y equals A here for inverse. Whereas, remember, for direct, it was Y over X equals A. Or you could say X over Y is a constant. You're dividing, doesn't matter. But you want a constant product of inverse. So any questions about those? Okay. So let's do some quick examples here. And then I want to talk about joint variation. Then I'll let you guys do some classwork after that. So in this case, as I was saying, Y equals 7 over X. That's x and y equals 5x. So if you look at A and C, those are inverse. Remember, inverse follows y equals a over x, or x times y equals a. So whenever you see that, that's inverse, because if you were to double x, y would get halved, and vice versa. Now these right here are going to be direct. Remember what direct represents. Direct is y equals a times x, or y over x equals a. So if I were to double x, y gets doubled. Or if I triple x, y gets tripled. Or quadruple x, y gets quadrupled. If I halve x, y gets halved. They go in the same direction. Now B and C are each neither. Let me illustrate with a quick table. What if x is 0? Y is 3. If x is 1, y is 4. If x is 2, y is 7. If x is 3, no, yikes. X is 2, y is 5. X is 3, y is 6. X is 4, y is 7. By doubling x, y doesn't double here, right? We went from 1 to 2 for x, we went from 4 to 5 for y. Or by tripling x, y doesn't get tripled here. So it doesn't follow that pattern. And plus, in order to be inverse, you need x and y to go in opposite directions, which they don't do here. So it doesn't follow inverse either. That's why it's neither. But look at the next one. X is 1, y is 1, x is 2, y is 4, x is 3, y is, and there's a pattern for sure. The pattern is squaring. Or if I do 1/2, I get 1/4. But notice how if I double x, y gets quadrupled. Or if I triple x, y goes up by 9. It's not inverse, obviously, because x and y are both going up. They're not going opposite directions. It's not direct because it's not a constant ratio between pairs of x, y values. In fact, the ratio here is 1, but here the ratio is 3. So that doesn't work for us. So that's also neither. So if you see, like, anything that doesn't follow what we kind of expect for direct and inverse, it doesn't, the equation is not in that similar kind of relationship, then you have to say neither. Look at 2, x, y vary inversely. So you're going to see some example problems just like this. So you totally vary inversely, easy. Y equals a over x. Plug in 7 for y. Plug in 4 for x. Solve for a. Two equations, y equals 28 over x. So we plug 4 in for x, of course, y is 7. So your constant variation is at 28. Find y when x equals -2. So now you have your equation, plug in -2, and you get -14. Boom. There you go. So you're going to see some problems just like that. Again, your total inverse, go straight to that formula, plug in the x and y values you're given, solve for a. Now you can write your equation that relates to x and y. The constant variation is obviously the numerator here, and then you can predict any other y value for a given x value using that equation. So don't overthink it. For 3, then we'll do a chemistry problem. I know some of you guys have done this stuff in chemistry if you're taking that class right now. But before we do the chemistry problem, okay, again, directly. So that means that P equals A times K is direct. Plug in the P and K values you're given. So A, of course, is 3. The equation is P equals 3K. This means that P is always 3 times whatever K is. Conservation is 3. And now you can predict what P is going to equal for a given K value. That's all. Again, very, very straightforward. It's good to know this because there are a lot of things that follow these kind of patterns. Everyone's talking about, the leveling off or flattening of the curves. That's what people are saying with coronavirus. If you kind of, this is totally different, by the way, what we're doing here, but if you kind of think about, like we didn't have any cases of coronavirus in the United States, and all of a sudden it just like went like this, and then we're kind of hoping it does this, right? It's still going to increase, but notice that the curve is flattening. So this is like time in days, we could say, and that could be like a number of COVID-19 cases. There's a pattern for that, right? That pattern might be exponential, could be logarithmic. There's a lot of different ways you can model it. I'm not going to get into that because that's just going to be too confusing for you guys. But it's not going to be linear, obviously. It's not going to be an inverse. Inverse actually would follow this, which is what we want, actually. We want the inverse because we want it to go down. That's like y equals 1 over x, by the way. If we graph that, looks like that. But we're going to talk about that later in this period. But it's just kind of good to understand relationships between variables, in this case, time and COVID-19 cases. Does anyone want to chime in as to what would impact? I know it's a little bit different what we're talking about, but why? Would the curve flatten? And also, why would it spike up? Anyone have any ideas of why it's flattening and how that's happening?
Because of social distancing, it's like there's like less cases in a shorter amount of time.
Yep, human behavior. That's really the big one. If you guys have been watching in the news, Donald Trump's kind of a wild ride if you want to watch the White House briefings. It was pretty interesting yesterday. But if you watch any of the governors like Andrew Cuomo from New York or Gavin Newsom from California, Andrew Cuomo was actually a really good person to listen to. He just was saying it's all about human behavior. If people stay home and cover their mouths, wear gloves, social distancing, then you would see an impact. And so you can see how math can be used to model, but of course, there are variables that sometimes we can't control, like human behavior. And of course, it would spike up if people don't listen, like when a lot of people went to Florida for spring break, and then they got other people sick, or if people decide to all go to the beach or amusement parks, or schools and sporting venues don't listen to the public health alerts, and they say, "Oh, we're going to just have everyone go back to school like usual, or we're going to have have 80,000 people in the football stadium." Then you're going to see something kind of like this. So that's kind of what we're really focusing on here, is just relationships between variables, and relationships can look a lot of different ways. Right now, all we're doing is direct, which is just going to be a line, or inverse, which is just going to be this. We're not doing any of this other stuff here, but we're going to talk about that in May because I think that's kind of interesting. And it's kind of relevant to what we're experiencing. But that's what graphs and equations really ever are. They're just relationships between two or more variables. And what can impact that relationship be a variety of things. And right now, it would be human behavior, but a lot of other things that can impact that. So let's talk about this example here, and then we'll talk about joint, and I'll have you guys do some practice. Okay, so So this is a chemistry example, not as exciting, but still very relevant. Boyle's law states that pressure on, here we go. Pressure varies inversely with volume. So that means that P equals A over V. Remember, the inverse variation was Y equals A over X. But you're replacing Y with P, you're replacing X with V. That's all. They said use K as a constant, so what the heck? Same thing. You know, A and K are both constants, doesn't really matter. So yeah, that's Boyle's law. So this means that pressure times volume is a constant. That's why when you see like high pressure in a chemistry lab or experiment, you're going to see low volume, and vice versa. So that's just kind of a relationship that manifests itself in the chemistry class. The last example where I have you guys do some practice problems. Joint variation. So joint variation is simply when one variable is directly impacted by two or more variables, which actually makes sense because it's rare that you only have one thing impact something. Like, for example, going back to coronavirus, what are some things that are impacting, you know, when you look at the number of days that pass and how many people have contracted the virus? Human behavior, but also lack of testing. I mean, that's another thing that you have to take in consideration. Maybe people's previous health conditions, age. You know, there's a lot of things that can impact that. So in real life, we want, you know, to look at multiple variables. So here, Z varies jointly with X and Y. Again, joint variation is totally different than coronavirus. That's just a much different modeling skill set that's really complex, but we're looking at something pretty basic here. Z varies joint with X and Y. P varies joint with Q, R, and S. A, we're still calling the constant variation. So we're told Y varies inversely with X. We're just going to kind of just go through these examples here. That's Y equals A over X. W varies jointly. So W equals A times X times Y times Z. Y varies inversely with the square of X. So you do inverse, we got square X. Y varies directly with Y, but inversely with X. Sorry, Z. So Z will equal A times Y, but you're going to divide by X because there's an inverse between Z and X. X varies jointly with T and R. Inversely with S. So inverse we got from the bottom, jointly is like direct, as I mentioned, but just with multiple variables. So that's what's happening with these examples here. Any questions so far before we do some practice problems? Oh, okay. So classwork, let me open that up. Problem sets, chapter 8. Yep. This is a good set here. And there's actually 6 problems. So I think it'd be good for you guys to do all, no, we won't do all 6. We'll just do the odds. So 1, 3, and 5. So I'm gonna put you guys in breakout rooms. So you may want to make sure you can take a picture of this with your cell phone if you don't have the packet out. If you do have the problem set packet, which I gave to you guys before we closed school, obviously use that. If you need to go to Schoology and download it, it's there. You can have that open. And you can write this down on a piece of paper. But it's just good for practice with you and a couple other people. So yeah, we're just gonna have you guys do 1, 3, 5, then we'll reconvene in about 10 minutes. Actually, I don't even need that much time. I just want to make it 8 minutes. I don't think I need that much time. So I'll make it 8 minutes. I'll have you guys just do 1, 3, and 5. And I'll kind of peek my head into each room to kind of see if things are going okay. So let me stop sharing and put you guys in breakout rooms. So you guys doing 8.1, 1, 3, 5. Let's go breakout rooms. We'll do 5 rooms. Automatically, I don't feel like manually doing them. Okay. So those are the rooms. 8 minutes. Oh, that's funny. I wonder if it heard my voice. I didn't even say 8 minutes. That's so, I mean, I thought it was 10 minutes before. Nothing time's up, blah, blah, blah. Yeah, okay. All right, so go in your rooms. I'll kind of just peek my head in every minute or so. You guys doing okay here?
Yeah, I'm good.
Good, very great. Oh, is this the fun room? You guys doing okay here?
Yeah.
Good, no questions, all right. Less than 4 minutes. Any questions so far with you three? No, we're okay?
Okay.
All right, we got about 3.5 minutes left.
Thank you.
Any questions over here? Nope, we're okay. All right, we got about 3 minutes left.
I don't. I think it's okay. Thank you.
Okay, great. Any questions over here?
No.
Yeah. Okay. Since we have about 2.5 minutes left, I might just increase that just a little bit longer so you guys have more time.
Okay, thank you.
Okay. All right, let me share my screen. I think everyone is back. 15, yeah, cool, everyone's back, great. So let's just go quickly go over those answers. And then we'll do a recap of A2 and A3. So if you look at number 1, remember you're told you have inverse variation here. So y equals k over x. I use k instead of a, but you know, in the notes we had a, so I'll just switch it up over here. So you know, y equals a over x, and then you simply plug in -4 for y and 5 for x, and k is -20. So that's your equation, y equals -20 over x. And then you're asked to find y when x equals 3. Easy, -20 thirds. There you go. This is all for number 2, so we'll just ignore that. So it's not confusing, and number 4 as well. And here you're told that z varies jointly with x and y. So that means z equals a times x times y. Use a instead of k. So plug in 24 for z, 2 and -6 for x and y respectively. X doesn't really matter which one goes because it's multiplication. Solve for k, get -2. So your equation z equals -2xy. Throw in -4 and 5 for x and y respectively. You get z is 40. Then for 5, this is actually like an SAT style problem. You're told that y is direct proportional to x, so y equals k times x. And you're told that y equals 20 when x is 6, so you solve for your constant variation. We'll use a for a constant variation. If you do that correctly, you get 10 thirds. If you reduce it. So that's your equation here. And then you're asked to solve for y when x is 9. So throw in 9, you get 30. You could also have done 20 over 6 equals y over 9. Because remember, y over x equals a constant. So you could have done that as well. 180 equals 6y. Y is 30. So that's another way you could approach those kind of problems, is you can set up a proportion. If it's inverse variation, then you want constant products. Then you would say x times y for one pair equals x times y for another pair, if you had that. So, okay, any questions about those 3 problems? Nope, we're okay. Okay, cool. So I'm going to clear this, and we're going to talk about some other problems here. So let's talk about 8.2 first. I think I did one of these problems. I think I did 7, and you guys had you guys do 8 or something like that. Let's take a look at 6. So let's kind of recap that one. Here we go. Here's number 6. So we talked about generally what's happening with these kind of problems here. Like we discussed that, okay, y equals a over x minus h plus k. Here our a is -3. Here our h is -2, mind you, because it's x plus 2. So you do x minus -2, and k, of course, is 0. This explains the shift of 2 left from the h value. No vertical shift because k is 0. And then -3 impacts all that, the reflection and the stretch. So what you could do for these problems is look at y equals 1 over x, which is very simple, like 1 and 2, -1, -2, work it out. But then remember, h is -2, so you're going to subtract x values by 2. A is -3, so you're going to multiply y values by -3. So you just alter this table here to do that. Or if you want to kind of straight from scratch, you could plug in, like, since your h was -2, you could plug in maybe like -1 and 0, and maybe -3 and -4. So deliberately choosing 2 x values higher than h and lower than h. And if you throw it into the equations here, you would get the same exact things as I got over here. If you throw into the equation, y equals -3 over x plus 2. So, you know, pretty easy. Then the domain's all real except -2 because you can't plug -2. And then the range is basically the k-value. The k-value is the exception, which k is 0. So we can't have 0 because -3 over a number can never be 0. Remember, the top's always -3. The bottom could be whatever. But even if you make x really big, y gets really close to it, but never exactly 0. So we want to clear that. And if you look at the drawing, it looks just like this. So remember, h impacts the vertical asymptotes. So we see x equals -2 right here. K impacts the horizontal asymptotes. That's why we see y equals 0. And then these other 2 points here, again, came from my table, right? Remember, we plugged in some values higher than -2 and some values lower than -2. And then we just threw it into the equation. Over here. So, yeah. Hopefully that all makes sense. Okay. So we'll go back to the breakout rooms again. And we have you guys just try doing a couple of these problems. So we're going to do, or you guys are going to do 4 and 5. So here are the equations. You might want to write those down or take a picture. So you're going to do 6 over x minus 1 and 5, you're going to do that. And just to give you a little bit of a push, I would suggest, because here your h is 1, and here your h is 0, I would suggest doing 2, 3, 0, and -1. So a couple of values higher than h, a couple of values lower than h. Here I suggest you guys do like 1 and 2 and -1 and -2. And that should help with making your table. You will need a VA and an HA, a VA and an HA. I'm not going to tell you what those are. You guys should be able to figure that out. So that kind of gives you a little bit of a head start for doing 4 and 5. So again, I'll put you guys back in breakout rooms again, and we'll just do a random assignment. And if you guys have questions, just someone in your group can just pop back into the main room and just ask. So does that make sense what I want you guys to do? Just 4 and 5 here. Okay, so let me stop sharing, go back to breakout rooms again. And we'll keep the same groups. So we'll just open the room, and I think 8 minutes is fine. Yeah. Right, so I'll put you back in your normal rooms again. Okay, looks like everyone should be back. 12, 15, waiting just for a few more people to come back in. Cool, great. So let me share my screen. Again, here's the answer key for 4 and 5. So for 4, remember I said H is 1. So I think picking 2 values higher than 1, like 2 and 3, and 2 values less than 1, actually, that made no sense there because you can't plug in 1. I don't know what I did wrong. Should be 0 and -1. Yeah, that's a typo. That should be a -1 right there. So yeah, so then you just plug into the original equation, get your values, and remember the vertical velocity was x equals 1. And the horizontal was y equals 0 because you don't have a k value. And there you go. There's your graph. So it should be pretty easy to do. Domain's all real except 1 because you can't plug in 1 and have that work. All real except 0 because remember your k value is 0. And here h is 0, so you're going to go 1, 2, -1, -2. And then just get the y values and you plug back the original equation. Domain's going to be all real except 0 because you can't divide by 0. All range is all real except -7 because your k is -7. So you have a horizontal asymptote y equals -7, vertical asymptote x equals 0. Plot your points. There you go. So any questions about how those turn out? No? Okay. So I will suggest that you guys do some of the remaining problems from that problem set. Even the lecture notes, I think there's some that we didn't quite do. Let me see here. One sec. Yeah, obviously for 8.1, there's always practice questions you guys can do. For 8.2, I don't think we did all these examples, so you could do those for practice. So I think that's kind of good. So we're looking for extra practice for our quiz next week. And again, the partners will be randomly assigned on the day of the quiz. I'll just let the breakout rooms do it for us. Yeah, so we'll maybe we'll look at 8.3 now, because I want to go over that with you guys. Yeah, maybe we'll do this one here. Yeah, there's lots of practice here. Let me make sure I have the answer key for this. It looks like I do. Yeah, that's good. So let me go to Schoology really quickly here. Make sure it's posted there. I'll do one example and we'll wrap it up for today. And then I'll suggest you guys to kind of work through that for practice. Video lecture notes, chapter 8. Yep, they're all there. And let me delete this one because we're not doing. Chapter 9. And we delete. I'll delete that one. Here we go. Okay, so let's do just a little bit of a practice here for chapter 8, section 8.3. Close that, close that, close that, close that. Okay. Oh, I'll open the blank one. So let's look at this one here. Okay, so this is on the back to the lecture notes. It's the second to last page. It's example 5 for section 8.3. So we're going back to the lecture notes packet. And we're going to talk about how to graph this one, 2x over x squared minus 16. So vertical asymptotes, remember, in case you forgot, set the denom equal to 0. X-intercept, you're going to set the numerator equal to 0. Y-intercept, you're going to plug in 0 for x. Horizontal asymptotes, you need to consider the 3 cases, which I'll go over in a little bit. And then we'll do a little table here, which is kind of like the sign chart. So you would get that for vertical asymptotes. For here, set the numerator equal to 0. So that's going to be the x-intercept, because that's where y will be 0. You put in 0 for x, you're going to get the same thing as you did for the x-intercepts. The 3 cases for this, in case you forgot. And generally speaking, we think of a rational function like this, m being the highest exponent for the numerator, n being the highest exponent for the denominator. Obviously, m here is 1. N is 2. So we're really looking at this case. So that's going to be my horizontal asymptote. My vertical asymptote, again, is x plus or minus 4. My horizontal will be y equals 0. If we do a sign chart, you're going to use the x-intercepts and the vertical asymptotes. So that's precisely why I have -4, 0, and 4 here. And then you want to go in between. And you want to go to the outsides. That's why we chose those numbers to plug in. Obviously, if you plug in -4 and 4, that's undefined. Plug in 0, 0. If I plug in 4, if I plug in 6, I know y is going to be positive. If I plug in 2, y is going to be negative. That's because if I plug 2 in, I get 4 up top, but -12 down below. -2, it's back to being positive again for y. If I plug in -6, I get -12 up top, but I get 36 minus 16 at the bottom. So overall, that's going to be negative. So now let me do my graph, and then we'll wrap it up for today. Darn, I wasn't really smart about this. I'm just gonna do the coordinate plane off here in the corner. So remember, vertical asymptotes, horizontal asymptotes. We have a point right here. That's only the real point I have, but remember, I'm expecting everything to the right of 4 to be positive, so I'm probably gonna have something kind of like this. I'm expecting everything to the left of 4 to be negative, so I'll probably have something like this. So you have the asymptotes guide the graph, and then it's positive from -4 to 0, but negative from 0 to 4. So I'll probably have something like that. And that's gonna be your graph. You remember the whole purpose of the asymptotes, you want the graph to kind of go against them. You can cross horizontal asymptotes in the middle, that's totally fine, but you can't have it cross on the far left and far right, because you want to get close to the horizontal asymptote when x is going towards positive or negative infinity. It's actually called the end behavior asymptote for that reason. It's how the ends of the graph will behave. So that's how that will look. We'll definitely talk more about that before the quiz on Monday in case you guys need a little more practice, but I'm going to suggest, I'll probably just put as a assignment that won't be worth any points, but I'll just suggest to do certain problems from the lecture notes and maybe from the classroom problem sets as well, just for extra practice. And you have all the answers up in Schoology. And office hours, I will be available. Actually, I need to earmark that. So I am. So I'll be over from 12:30 to 2 this Friday. So feel free to swing by if you have any questions. And I think that pretty much covers, unless there's any burning questions of how I did exam 5 here on the lecture notes for 8.3. Nope. Okay. I will make sure I upload this recording and I'll share it with you guys as an update through Schoology. And I still think I have some other videos to post as well from the week before spring break. So I'll make sure that all that's updated, and I'll again suggest some problems for you guys to do. We should be able to take care of all that by later this evening. Any questions at all before we sign off? Nope. Okay. So yeah, if you have any questions, you can email me during office hours. You know, watch some of the videos. We will have a quiz next week on this stuff. Again, it will be one question from sections. It's 3 questions total. One from 8.1, one from 8.2, and one from 8.3. So yeah, definitely spend some time practicing this week, and we'll do this again on Monday afternoon at 12:30. Okay.
Thank you.
I'll see you guys later.
Thank you.
Bye.
Thank you.
Yeah.
Thank you.
Bye.